Good afternoon, students. We have already discussed about the classification of acids. Okay, but I want to say you something about the organic acids and inorganic acids. See, first of all, you all know organic acids means which are obtained from plants, animals, and tissues. Like as acetic acid, this is found in vinegar. Formic acid, it is found in sting of an ant. Malic acid, it is found in an apple. It is found in an apple, and citric acid, it is found in lemon. Okay, like that. Now there are these organic acid are generally weak acid. Okay, weak acid means what? They doesn't give that much of H plus ion in solution. So first of all, acetic acid is also organic acid. So first of all, we have taken a beaker, and here we have taken some amount of acetic acid, that means CH3COOH. So we all know this acetic acid is weak acid. It cannot dissociate completely. Is this clear? First of all, see, let us consider 100 molecules of acetic acid we have taken in this beaker. After dissociation, we have got, that means after dissociation of this acetic acid, we have got some acetate ion, that means CH3COO minus ion and H plus ions, because this is the acid, it always give the H plus ion. But if we have taken 100 molecules of acetic acid, only 10 molecules of acetic acid will be dissociate. Is this clear? That means dissociation takes place only 90 molecules, sorry, only 10 molecules. Okay, and undissociate molecules remaining as a 90 molecules. Is this clear? Okay, now that's why this is called as a weak acid. Same thing is happening in case of formic acid. This is also weak acid. Okay, now first of all, this acetic acid only furnish some amount of H plus acid and acetate ions. If you take 100 molecules of acetic acid, only 10 molecules of acetic acid give H plus ion, but 90 molecules of acetic acid remaining same in this solution. Is this clear? That's why this is called as a weak acid. Okay, now so in solution of weak acid, it contains ions and molecules both. Okay, so in solution of weak acid, both are present. Both means what? Both means ions as well as molecules. Both are present in the solution of ions and molecules. Both are present in the solution of weak acid. Okay, now in case of mineral acid we all know, that means that is the another name is the inorganic acid. Now mineral acid, which are obtained usually from the minerals, that are very strong acid. They are very strong acid. If you take, or if we take some HCl acid, it furnish, see, this is the beaker. If you take some amount of HCl, this is also the mineral acid. Mineral acid means what? Give some examples of the mineral acid like that. HCl, H2SO4, nitric acid, carbonic acid, phosphoric acid, sulfurous acid, they all are the kind of mineral acid. Okay, now we all know generally mineral acids are strong. Now if we take some amount of HCl in beaker, then what happened? Let us consider here 100 molecule of HCl, 100 molecules of HCl are present in this acid. Okay, in this solution. Now after that, complete dissociation takes place. In case of strong acid or mineral acid, they are generally strong means complete dissociation takes place. If I have taken 100 molecules of hydrochloric acid, then 100 molecules of hydrochloric acid will be dissociate and give us completely 100 molecules of H plus ion and 100 molecules of Cl minus ion. Is this clear? Okay, that means here complete dissociation takes place. Okay, we have got completely, if we have taken 100 molecules of HCl in 100 molecules of HCl in this solution, then we have got 100 molecules of 100 molecules of H plus ion and also 100 molecules of Cl minus ion. Okay, this is the nature of the strong acid. That means in case of strong acid, complete dissociation takes place, but in case of weak acid, that means acetic acid, formic acid, that means dissociation not incomplete dissociation takes place. Okay, dissociation is not completed. Is this clear? Okay. Now, but in the mineral acid, here has an exception. Okay, mineral acid we all know this used as a strong acid, but here also exception is present. We all know as a carbonic acid, what is the formula of the carbonic acid? This is the formula of carbonic acid, H2CO3. It is a mineral acid, but it is its nature is as a weak acid. Okay, because weak acid means it doesn't dissociate completely. Okay, this is the exception, only one exception. So here is a question, what will be the solution of carbonic acid contains? That means what will be the solution of carbonic acid contains? We know it is mineral acid, that means this is mineral acid, but it is the generally weak acid. Is this clear? So only ions and molecules both are present in the solution of the carbonic acid. So what is the name of this acid? This is the carbonic acid. Okay, now we'll move to the next topic, that is the preparation of acids. Okay, how will we prepare the acids? See, open to page number 40 in your book. Now, so first process is preparation of acids. So first process is direct combination or synthesis. Okay, direct combination of synthesis or synthesis. So see, first of all, combination of non-metal with hydrogen. Here has a trick for all of you. See, from non-metal we always get acid. Is this clear? Non-metal means it has a common tendency, or it has a tendency to accept electron pair. Okay, that means give some example. Carbon, sulfur, nitrogen, oxygen, they all are the kind of non-metals. But metals, from metals we always get base. Is this clear? This is the trick. Okay, so from non-metal we will get acid, and from metal we will get the base. Now first process is combination of non-metal with hydrogen. Okay, so here is another name, direct combination, or you can say this is the synthesis. Is this clear? Now this is the general reaction. When non-metal react with hydrogen, then we will get some acid. Okay, here has a example. Chlorine is also non-metal. Non-metal means we all know chlorine is halogen, and when chlorine is react with hydrogen in gaseous form, both are present in gaseous form, then we will get some HCl as a gaseous form. If you have taken this HCl gas in water, then in water HCl is more soluble. Okay, after soluble in water, HCl gas turns to acid. Okay, then we will get some hydrochloric acid from HCl gas. Is this clear? Okay, now similarly this reaction, bromine is also non-metal, that means this is also halogen. When bromine is react with hydrogen, then we will get the hydrobromic acid. What is the name of this? This is the hydrogen bromide as a gas. After soluble in water, we will get some acid. Okay, so what is the hydrogen chloride? Okay, then hydrochloric acid. This is hydrogen bromide, then we will get the hydrobromic acid. Okay, now sulfur, here sulfur is also present as a non-metal. Sulfur when react with hydrogen, then we will get hydrogen sulfide. It also acts as an acid. Okay, this is the first process. Second process is second process of the preparation of acids is by the action of water on non-metallic. See, here also non-metal is present, or acidic oxides. Okay, by the action of water on non-metallic or acidic oxides. See, when non-metallic oxides means what? Non-metallic oxide or non-metal oxide means what? When non-metal react with oxygen, then non-metallic oxides are formed. First of all, see, carbon is non-metal. It react with oxygen, then carbon dioxide is formed. That means we can say carbon dioxide as a non-metal oxide. Is this clear? So when non-metallic oxide or non-metal oxide react with water, then we have got acid. Okay, see, this is the example. Carbon dioxide react with water, then we have got some carbonic acid, H2CO3. Okay, now the next reaction is, what is the name of this? Sulfur trioxide, SO3. When sulfur trioxide is react with water, then we have got sulfuric acid. Very easy. And like as sulfur dioxide when react with water, we have got some H2SO3. See, here SO4 sulfate ion is present, and here SO3 sulfite ion is present. Is this clear? Sulfate ion is present, that's why the name of this acid is sulfuric acid, and here sulfite ion is present, that means the name of this acid is sulfurous acid. Okay. Now in case of nitrogen dioxide, when nitrogen dioxide react with water, then you are thinking about we have got some nitric acid, but no, here both of the acid we have got, both acid, that means nitric acid as well as nitrous acid, we have got the two acid, because this nitrogen dioxide acts as a mixed anhydride. Okay, this nitrogen dioxide acts as a mixed anhydride, that's why we have got the two different mixture of this acid. First of all, nitric acid, and mixture of the nitric acid and nitrous acid. Okay, so this is the second process of the preparation of acid. Now third process is oxidation of non-metal. Okay, oxidation of non-metal. In chemistry, nitric acid is a very strong oxidizing agent. Okay, oxidizing agent means what? What is the definition of oxidizing agent? Oxidizing agent means what? It can oxidize anything. Okay, it can oxidize anything. Anything means here only we'll use only C. Here also present non-metal. So first of all, we have taken sulfur. Okay, in case of sulfur, in presence of sulfur, that means in presence of sulfur, this sulfur when react with nitric acid, this is very strong oxidizing agent. This nitric acid oxidize sulfur, and we have got some sulfuric acid. Is this clear? We have got some sulfuric acid. Okay, and then water and also nitrogen dioxide, this byproduct we have also got. Okay, but this one is the major product, and both these two are minor product. Okay, now same kind of this reaction is this. First of all, this phosphorus, when phosphorus react with nitric acid oxidize phosphorus, and then we have got some phosphoric acid. What is the name of this acid? This is the phosphoric acid. Okay, and also see, same compound, same binary products we have got from this type of reaction and this type of reaction. See, water, here water, nitrogen dioxide and nitrogen dioxide. Okay, these binary products are same, but here has a difference. We have got some in case of sulfur we have got some sulfuric acid, and in case of phosphorus we have got some phosphoric acid. Okay, but here see, carbon, we all know carbon is also acts as a non-metal. Okay, now see what happened when carbon react with nitric acid. You are thinking we have got some carbonic acid. Yes, obviously we have got some carbonic acid, but I have already discussed carbonic acid is mineral acid, but this is very weak acid. Okay, so it doesn't exist like that. It doesn't exist like that. Okay, because this is very weak acid. Very weak acid means what? It decomposes into water and carbon dioxide. Okay, in case of carbon, when carbon react with nitric acid, we doesn't get any other kind of acid. We only get water and carbon dioxide gas and also nitrogen dioxide gas. Both of the gases we have got from this reaction. Okay, this is very important reaction for you. Now the last method is by displacement. Okay, this method is used only for the preparation of volatile acid. Okay, here is a new term, volatile acid. Volatile, you all know what is the definition of volatile acid, or what is the meaning of the volatile acid. Volatile acid means, volatile acid is such an acid which can evaporate easily. Okay, which can evaporate easily. First of all, if you have taken some HCl outside in the atmosphere at room temperature, they will evaporate immediately and turn into its gaseous state. Okay, is this clear? This is called volatile acid. So what will be the examples of volatile acid? So HCl, you can say HCl, HNO3, these two acids are volatile acids. But what is the definition of non-volatile acid? They can never easily evaporate. Okay, they can never easily evaporate in atmosphere. Okay, now this is the reaction. See, from salt. Okay, we can prepare the volatile acid from salt and non-volatile acid. Okay, now from salt, here you will use any other kind of salt, sodium chloride, magnesium chloride, okay, potassium chloride. Is this clear? So first of all, from salt, here non-volatile acid, from salt we have got some volatile acid. So first of all, we have taken some sodium chloride as a salt. When sodium chloride is react with sulfuric acid, okay, then we have got some sodium hydrogen sulfate and hydrogen chloride. But here is a condition, the temperature of for this reaction will remain below 200 degrees centigrade. Okay, see here, we all know this NaCl, when NaCl is react with sulfuric acid, then we have got NaHSO4 and HCl. See, what is the mechanism of this reaction? See, in case of sulfuric acid, only one H plus ion comes out from this sulfuric acid, okay, due to the low temperature. Okay, so this one H plus ion comes out from the sulfuric acid, and this H plus ion goes towards this Cl minus H and Cl, then they can join together and form the HCl gas. Then what will be remaining? NaHSO4, sodium hydrogen sulfate. Okay, this is the mechanism of this reaction. How? See, first of all, it only give one H, okay, as a H plus ion. Okay, so how will it dissociate? H plus HSO4 minus. Is this clear? Okay, after that, this H goes towards this Cl, that means this H plus has taken this Cl minus ion from this NaCl. Okay, now it combines and form HCl, and then what will be remaining? Na and HSO4 minus. See, Na plus and HSO4 minus come closer to each other and join together and form this NaHSO4. See, but here is a problem. We know H2SO4 always acts as a dibasic acid. I have already told you now, the basicity of sulfuric acid is 2. But see, here in this reaction, the basicity of sulfuric acid will be 1. Why? Because see, this sulfuric acid gives only one H plus ion. Is this clear? Okay, so basicity is also depends upon the reaction medium. Is this clear? See, we know H2SO4 acts as a dibasic acid, but only this reaction, the basicity of sulfuric acid will be 1. Why? Due to the low temperature of, why? Due to the low temperature, only one H plus ion comes out from H2SO4. Is this clear? So basicity is also depends upon the reaction. Okay, so in this reaction, the basicity of sulfuric acid will be 1. Okay, now the next reaction is sodium nitrate is react with sulfuric acid, also react with sulfuric acid. See, also temperature will be below the 200 degrees centigrade. Then we have formed this some sodium hydrogen sulfate and nitric acid. Is this clear? You can take potassium in place of sodium. Okay, so this is the preparation of acid. Thank you.